Hi there, welcome to this video on transformation of curves. I'm just going to focus on translations on this particular video, and I'll put up a video on the other types of transformations of curves. So imagine that we had y equals x squared. Well, if we had a table of x and y, then all we're doing is squaring the x values to get y, and it would look something like this. And then if we plotted the points for x and y, we'd end up with this curve. It's the parabola for y equals x squared. So it's this curve shape, this U shape. Now, what you need to understand is this terminology. So this is almost like another way of writing y. So we can say there's a function of x which is x squared. So that means that whatever x values we get, we're going to square them to get our output. So we're putting in x, we're squaring it to get our output, and that's what's going on in this one. So that's important to understand what this is. It won't always be x squared, of course. This is just showing you how it all ties in. So for this one here, we're looking at f of x plus 2. So I'm going to show you what happens if we add a number to our x value before we start squaring it. So this is what it would look like in our number machine system. So if we start with x and then we add 2 before we square it, then we're going to consider what happens. So this was the original y equals x squared. So this is what we started with. Now, if I add 2 to these numbers here before I square them, let's take this one for instance. So if I started with 1 but add 2 before I square it, effectively I'm squaring the number 3 and 9 comes out. Now, what that means is every time I put in an x value, the number coming out is actually the number that was 2 to the right on our original. So let's see what that looks like on our diagram. So in the original y equals x squared, let's say we put in 1, we got 1 out. If we put 2 in, we got 4 out. If we put 3 in, we got 9 out, and so on. But now what we're going to do is we're going to add 2 before we square. So this is, if y equals x squared was our function in x, now we're going to do f of x plus 2. So instead of just putting in x in, we're going to add 2 to the values before we square it. So let's see how this will affect what we end up with. So now if we put in 1, we're going to add 2 and 9 comes out. So 1, 9 comes out. So effectively that point that was here before is now shifted 2 to the left. If I put in 0, we would add 2 before we square it to give us 4. So now when I put in 0, 4 is coming out, whereas before I had to put in 2 to get 4 coming out. So again, this point's moved to the left too. And what's actually happening, if I just sketch over this, it's actually easier to show you like this. What's happening is this original curve, f of x, which was y equals x squared, has now just moved over to the left by 2. And this is what happens when you add something before you square it, or whatever it is, cube it, or whatever the function is, everything will move to the left or to the right, depending on what this number is. So if you add something like 2, it'll move 2 to the left. If you add 4, it'll move 4 to the left. Now, if you subtract a number, the opposite will happen. It'll move to the right. So if I did f of x minus 6, everything will move to the right by 6. Okay? So, in general, a horizontal translation, so horizontal, left and right, translation moves to left or right, will happen if we add something or subtract something to our x values before we perform the function, the squaring part in the example we showed. So if I want to say add 2, so if I did f of x plus 2 as we just saw, that will move the whole graph to the left. If I did f of x minus 4, the whole graph will move right 4, and so on. So that's one type of example that you need to be aware of. Now, the other sort is, so before we saw in brackets that we added 2. Now this one is f of x plus 2. So we had to do the squaring first and then we add 2, or whatever we're going to do, whatever we add. So this time we put in our value of x, we square it, and then we add 2. So let's go back to the original thing that we looked at. Remember, f of x was our original function, which was y equals x squared in this case. Now, all we're going to do is we're going to put in our value of x, let's say 1, we square it, we get 1 out, but then we add 2. So we're actually going to get 3 coming out. If I put in 2 and square it, I get 4, and then we're going to add 2. So what's happening is that all of these y values that we had in the original are now just going to be 2 more. So our f of x plus 2 just means that we're going to end up with 2 more than our original. So that y value there, if you look at 2 going in, it gave us 4 in our original function. But now, when we put 2 in, because we add 2 onto that after squaring it, we end up with 6 coming out. So if I put in 2, 6 comes out. If I put in 1, 3 comes out. If I put in 0, 2 comes out. So you can see that what's happening is this curve has moved up by 2. So if I just show you how that moves, you can see that the curve moves up by 2 because you've added on 2 to all the original y values. So the y values now are all 2 more than they would have been with our original function in x, which is y equals x squared. So in general, if we have a function and we do whatever that function is, squaring in the examples we've been looking at, and then add a value, everything moves up. So if I did f of x and then subtracted 2, what we'd end up with is this whole curve would move down by 2. All the y values would be 2 less than they were originally. If I did f of x plus 6, everything would move up by a value of 6. So the whole curve would move up by 6. And this is a vertical translation, so this is up and down movement. So let's start to consider exam questions then. So here's a typical one. The graph of y equals f of x is shown on the grid. So notice that they don't tell us what that is. We could work it out, but it's not important. On this grid, sketch the graph of y equals f of x plus 2. So this is an example where we do the function and then we add 2. So all the y values are going to be 2 more than they were before, so everything moves up by 2. So here we go. So this is what we end up with. So it's easy to think of all the points that are easy to see, so those ones, and just make sure that they're 2 above where they were before, and you've done that one. So this one, the diagram shows part of the curve with the equation y equals f of x. The coordinates of the maximum point of the curve are 2, 3. Write down the coordinates of the maximum point of the curve with the equation y equals f of x minus 2. So this is an example where we are subtracting 2 before we do the function. So remember, when we do it before we do the function, the translation is in the opposite direction to what you might think. So we're taking away 2, so everything actually moves to the right. So this whole curve is going to move 2 to the right. So that's where it ends up. This is just a sketch, of course. So if you think about it, because everything's moved to the right by 2, clearly the y value hasn't changed. It's not gone any higher or lower, so the second number hasn't been altered at all. But the first number has moved from 2 to 2 to the right, which is now 4. So the x-coordinate has changed by a value of 2, and the y-coordinates stay the same. So if you have a horizontal change, the x-coordinate will change, but not the y-coordinate. If you have a vertical change, the y-coordinate changes, but not the x-coordinate. So write down the coordinates of the maximum point, so we can see that it would be 4, 3. Okay, the curve with the equation y equals f of x is translated so the point 0, 0 is mapped onto the point 4, 0. So that basically means that it's moved from there to here. Find the equation of the translated curve. So it's moved to the right, so it's a horizontal translation, so that means that our function was affected before we performed the function. So the x value was changed before we squared it or whatever it was. So if we had our f of x before here, what we've done is we've moved to the right 4. Now lots of people put down it's plus 4, but remember the actual thing we write down is the opposite to what you might think. So it's actually f of x minus 4. So we take away 4 before we perform the function. So everything has moved right by 4 units. So that's our equation of the translated curve. Okay, last one then. So this is a sketch of the curve with the equation y equals f of x. The only minimum point of the curve, which is the lowest point of the curve, is 3 minus 4. Write down the coordinates of the minimum point of the curve with the equation y equals f of x minus 2. So this is a translation, a horizontal translation, because we have performed the change in x. We've taken away 2 from x before we perform the translation, before we perform the function, So what we need to do is we need to move everything to the right by 2. So again, if everything moves to the right by 2, we end up with something over here, like that. So you can see the y value won't change, but the x value is 2 more than it was before. So instead of being 3, it's 2 bigger, which is 5, and the y value stays the same. Right, last one on here. So this one, you can see we've actually got 2 things going on. We're going to add 5 before we perform the function, and then add 6 after we perform the function. So adding 5 before we perform the function is going to move everything to the left by 5. So everything to the left by 5. So the x value is going to be 5 smaller than it was before. So if I take 5 off 3, we get minus 2. Now, this part, so we're adding after we perform the function, is going to make the curve move up by 6 units. So it was minus 4, but it's now going to be over here somewhere. Remember, it's already moved left, so it's actually going to end up somewhere around here, because it's moved left by 5 and now moved up by 6. 6 bigger than minus 4 is 2. So that's our new coordinate for this one. Okay, well, I hope that's helped, and have a look at the videos on stretches and reflections as well. Thank you.